All right, so let's go ahead and get started with example one. And so we're going to need the Pythagorean identity that we were using, or that we derived earlier to find the value of sine. And then also, once we find the value of sine, we'll be able to get tangent. So we know that the identity is cosine squared of theta plus sine squared of theta is equal to 1. And we already have the value of cosine of theta. Cosine of theta is equal to 2/5. All right, and in the identity we want cosine squared, so let's just go ahead and square this, right? So once we square this, we'll get the value of cosine squared. And so cosine squared of theta is equal to 4/25. All right, and so the next step is up to you guys, however you want to do it. And so me personally, I like to rearrange my equation so that I have it solved for what I'm looking for, and I'm looking for sine. So before I plug anything in, I'm just going to go ahead and do that. All right, and so I have cosine squared plus sine squared theta is equal to 1, but I want sine by itself, so I'm going to subtract cosine squared theta on both sides. I'm going to be left with sine square of theta is equal to 1 minus cosine squared theta, right? But then I need to take the square root of both sides. All right, once I do that, I'm going to get sine of theta is equal to the square root of 1 minus cosine squared of theta. All right, and so now I have it solved for sine of theta, so now I'm going to plug in the value of cosine squared theta in there. All right, so I'm going to get sine of theta is equal to the square root of 1 minus 4/25, or 4/25, and so that's equal to the square root of 21 divided by 25. All right. Oh, and then one thing that I forgot is that whenever we take the square root of a number, right, really we get two roots, right? We get a positive root and we get a negative root. So let's not forget to include that because that's going to matter later on, positive or negative. All right, cool. And then we can simplify this even more. So we're going to get that the sine of theta is going to be equal to the square root of 21 divided by 5, right? Because we can split this up into two different square roots, one for the bottom and then one for the top. And the square root of 25, that's a perfect square, right? So we know sine of theta is plus or minus the square root of 21/5. But now, is it going to be plus or is it going to be minus? Do we want the positive root or do we want the negative root, right? Take a moment and answer the Edpuzzle question now. All right, cool. And so hopefully you guys were able to figure out that what it's going to decide this for us is what quadrant we're in. And we're in the fourth quadrant. And we know that all of the sine values in the fourth quadrant are going to be negative, right? So we're going to take the negative version of this answer. Let's go ahead and erase this. Oops, I didn't want to erase the whole thing, but it's okay. I'll rewrite it. Okay. So we're going to get that sine of theta is equal to negative square root of 21 divided by 5. Cool. Now that we have the value of sine, we can get the value of tangent, because tangent of theta is equal to sine of theta divided by cosine of theta. All right, and now we know that sine of theta is negative square root of 21 divided by 5, and we know that cosine of theta is 2 divided by 5, right? And so let's divide this by hand. When we divide this by hand, we get that tangent of theta is equal to negative square root of 21 divided by 5. And then since we're dividing two fractions, we can go ahead and take the reciprocal of the second fraction and then turn this to multiplication. Becomes times 5/2. Oops. Hold on. It becomes 5 divided by 2. Okay. Where am I? And then, oops, sorry. There we go, 5 divided by 2. And so then this simplifies out to negative square root of 21 divided by 2. And that is our final answer.